Hello children, how are you all? Welcome to class 3. Today, we are going to learn mathematics which we use in our day-to-day life. In class 2, we have learnt about 2-digit and 3-digit number. Now, in class 3, we are going to learn about 4-digit numbers with the help of an abacus and place value chart, addition and subtraction of 4-digit numbers, numbers above 10 in tables, distribution and regrouping in multiplication and division, more in fractions, geometry, money, time, and metric measures. You will find it easier and understand mathematics better with the step-by-step explanation given in this DVD in each and every sum. Let us now start with the chapter numbers. Numbers. 4-digit numbers. In our previous classes, we have learnt about 2-digit and 3-digit numbers. We know that the smallest 2-digit number is 10. The largest 2-digit number is 99. The smallest 3-digit number is 100. The largest 3-digit number is 999. Now let us know about 4-digit numbers. When you add 1 to the largest 3-digit number, that is 999, we get a 4-digit number. We read this as 1000. In words, we write it as 1000. 1000 is the smallest 4-digit number. It stands in the 4th place in the place value chart. The largest 4-digit number is 9,999. 4-digit number on an abacus. Let us read about 4-digit number with the help of an abacus. Count the number of beads in the spikes that shows ones, tens, hundreds and thousands respectively. We have 5 beads in the ones column. We have 2 beads in the tens column. We have 3 beads in the hundreds column. And we have 4 beads in the thousands column. The same numerals may be written in the place value chart like this: 4,325. Now, let us try some examples. Let us arrange these 4-digit numbers in the place value chart and write their number names. 6,534. Write 4 in the ones column. Write 3 in the tens column. 5 in the hundreds column and 6 in the thousands column. Now, we have 6 thousands, 5 hundreds, 3 tens and 4 ones. We write it as 6,534. Next, we will take 8,987. Write 7 in the ones column, 8 in the tens column, 9 in the hundreds column and 8 in the thousands column. So, we have 8,000, 900s, 8 tens and 7 ones. We write this as 8,987. The next number is 3,475. Bring 5 to the ones column, 7 to the tens column, 4 to the hundreds column and 3 to the thousands column. We have 3 thousands, 400s, 7 tenths and 5 ones. We write this as 3,475 only. Next is 2,190. Bring 0 to the ones column, 9 to the tens column, 1 to the hundreds column, and 2 to the thousands column. We have 2,000s, 100s, 9 tens, and 0 ones. We write this as 2,190. Next is 5,566. Bring 6 to the ones column, 6 to the tens column, 5 to the hundreds column, and 5 to the thousands column. Now we have 5,000s, 500s, 6 tens, and 6 ones. We write this as 5,566. Let us write the numerals for the given number names. 1,987. We have 1,900, 8 tens, and 7 ones. We write this as 1987. 7,566. We have 7,000s, 500s, 6 tens, and 6 ones. We write this as 7566. 4,567. We have 4,000s, 500s, 6 tens, and 7 ones. We write this as 4567. Next, we will read the abacus and write the numerals and the number names. In this abacus, we have 6 beads in the ones column, 3 beads in the tens column, 2 beads in the hundreds column, and 5 beads in the thousands column. We write this as 5236. We write this in words as 5,236. In this abacus, we have 1 bead in the ones column, 4 beads in the tens column, 2 beads in the hundreds column, and 3 beads in the thousands column. We write this as 3241. We write this in words as 3,241. Face value of a digit in a numeral. The face value of a digit in a numeral will remain the same at whatever place it stands. There will be no change in the value. Thus, in the numeral 9876, the face value of 6 is only 6. The face value of 7 is only 7. The face value of 8 is only 8. And the face value of 9 is 9. Place value of a digit in a numeral. The place value of a digit in a numeral depends upon its position in the place value chart. Let us see an example by using a 4-digit number. First, let us arrange 6,879 in the place value chart. The place value of 9 will be 9 ones, which is equal to 9. The place value of 7 will be 7 tens, which is equal to 70. The place value of 8 will be 8 hundreds, which is equal to 800. And the place value of 6 will be 6 thousandths, which is equal to 6,000. Numerals in expanded form. A numeral, when expressed as a sum of the place values of its digits, is said to be in its expanded form. Let us see this with an example. Place the number 9876 in the place value chart. 9876 is equal to 9 thousandths plus 8 hundredths plus 7 tenths plus 6 ones, which is equal to 9,000 plus 800 plus 70 plus 6. This is called the expanded form of the number 9,876. Successor of a number. The number that comes just after a particular number is called its successor. In the numerical order, the successor of a number is one more than the number. The successor of 5 is 5 plus 1, that is 6. The successor of 25 is 25 plus 1, that is 26. The successor of 125 is 125 plus 1, which is 126, and so on. Predecessor of a number. The number that comes just before a particular number is called its predecessor. In the numerical order, the predecessor of a number is 1 less than the number. The predecessor of 5 is 5 minus 1, that is 4. The predecessor of 25 is 25 minus 1, that is 24. The predecessor of 125 is 125 minus 1, that is 124. Comparison of numbers. Let us first learn the rules for comparison. Rule 1. First compare the digits at the leftmost place in both the numbers. Rule 2. If they are equal, compare the second digits from the left. Rule 3. If the second digits from the left are also equal, then compare the third digits from the left. Rule 4. Continue in the same way until you find unequal digits at the same place. Then, find the number which is greater by comparing the unequal digits. Let us see an example. Compare 8765 and 9876. Both the numbers are 4-digit numbers. Compare their digits at the leftmost place. The digit is 8 in the first number and 9 in the second number. So you know 9 is greater than 8. So 9,876 is greater than 8,765. See another example. Compare 8765 and 8764. Both are 4-digit numbers. Both have same number in the thousands place, that is 8. Both have same number in the hundreds place, that is 7. Both have the same number in tens place too, that is 6. Now, let us see the ones place. Here, the number is different. It is 5 in the first number and 4 in the second number. So, 8,765 is greater than 8,764. Ordering of numbers. There are 2 types of ordering numbers, namely ascending order and descending order. The numbers are arranged using the comparison rules. When given numbers are arranged from the greatest to the smallest, it is called the descending order. Example is 8,000, 7,000, 6,000, 5,000, and so on. When the given numbers are arranged from the smallest to the greatest, it is called the ascending order. Example for this is 1,000, 2,000, 3,000, 4,000, and so on. Addition. Addition without carrying. Step 1. Arrange the digits of the given numbers in columns of thousands, hundreds, tens, and ones. Step 2. First add the numbers in the ones column and write down the answer. Then add the numbers in the tens column. Then the numbers in the hundreds column. And finally add the numbers in the thousands column. Let us try some examples. Add 4358 and 3621. Adding ones. 8 ones and 1 ones will give you 9 ones. We write 9 under the ones column. Adding tens. 5 tens and 2 tens will give you 7 tens. We write 7 under the tens column. Adding hundreds. 3 hundreds and 6 hundreds gives you 9 hundreds. We write 9 under the hundreds column. Adding thousands. 4 thousands and 3 thousands will give you 7 thousands. We write 7 under the thousands column. Thus, we arrive at the answer. Example 2. Add 2345, 3452 and 4102. First, arrange the numbers in column of ones, tens, hundreds and thousands. Now, add the numbers in the ones column. 5 ones plus 2 ones plus 2 ones is equal to 9 ones. 4 tens plus 5 tens plus 0 tens is equal to 9 tens. 3 hundreds plus 4 hundreds plus 100 is equal to 8 hundreds. 2 thousands plus 3 thousands plus 4 thousands is equal to 9 thousands. The answer will be 9,000 plus 8 hundreds plus 9 tens plus 9 ones. We write it as 9,899. Hence the sum of given numbers is 9,899. Addition with carrying. When the numbers in the columns exceed single digit, we follow the carryover method. Let us see an example to understand this concept better. Take two numbers, 4,567 and 3,678. Arrange them in columns as usual. Add ones column. 7 ones plus 8 ones will give you 15, which is 5 ones and 1 tens. You cannot write 15 as the answer in the column below. So, we take 5 ones to the column below and carry over 1 tens to the top of tens column. Now add tens column. 6 tens plus 7 tens plus 1 ten, which was carried over from adding ones column, gives you 14. Write down 4 below the tens column and carry over 1 to the hundreds column. Now add hundreds column. 5 hundreds plus 6 hundreds plus 100, which was carried over. We get 12. Write 2 below the hundreds column and carry over 1 to the thousands column. Now add thousands. 4 thousands plus 3 thousands plus 1,000 which was carried over. We get 8. Now write 8 below the thousands column. We arrive at an answer of 8,245. Example 2. Add 1,234, 2,345 and 3,456. Add ones column first. 4 plus 5 plus 6 is equal to 15. Write 5 below the ones column and carry over 1 to the tens column. Add tens column. 3 plus 4 plus 5 plus 1 carryover number is equal to 13. Write 3 below the tens column and carry over 1 to the hundreds column. Add hundreds column. 2 plus 3 plus 4 plus 1 carry over number, we get 10. Write 0 in the hundreds column and carry over 1 to the thousands column. Now add the thousands column. 1 plus 2 plus 3 plus 1 carry over number, we get 7. Write down 7 below the thousands column. The final answer arrived will be 7,035. Properties of addition. Commutative property of addition. Two numbers when added in any order will give you the same answer. This property of addition is called the commutative property. Let us see some examples. Let us take two numbers, 89 and 72. Arrange them in a column and add these numbers. 89 plus 72, we get 161. Now change the order in the column and add them. 72 plus 89. The answer is the same, 161. So 89 plus 72 is equal to 72 plus 89. Example 2. Add 1,368 and 2,678. Arrange them in a column and add these numbers. 1,368 plus 2,678. We get 4,046. Now change the order in the column and add them. 2,678 plus 1,368. Again, we get the same answer, 4,046. Associative property of addition. The sum of 3 or more numbers does not change even when their grouping is changed. For example, take these numbers 1,234 plus 2,345 plus 3,456 as example. Arrange the first two numbers in column and add 1,234 plus 2,345. Add ones column. 4 plus 5 is equal to 9. Add tens column. 3 plus 4 is equal to 7. Add hundreds column. 2 plus 3 is equal to 5. Add thousands column. 1 plus 2 is equal to 3. We get a total of 3,579. Now add the third number, 3,456, to the total arrived. 3,579 plus 3,456. Add ones column. 9 plus 6 is equal to 15. Write 5 below the ones column and carry over 1 to the tens column. Add tens column 7 plus 5 plus 1, which is equal to 13. Write 3 below the tens column and carry over 1 to the hundreds column. Now add the hundreds column. 5 plus 4 plus 1 is equal to 10. Write 0 below the hundreds column and carry over 1 to the thousands column. Add thousands column. 3 plus 3 plus 1 is equal to 7. We get a total of 7,035. Now change the grouping and find the sum of 1,234 plus 2,345 plus 3,456. Arrange the second and the third numbers in a column. 2,345 plus 3,456. Add ones. 5 plus 6 is equal to 11. Write 1 below the ones column and carry over 1 to the tens column. Add the tens column. 4 plus 5 plus 1 is equal to 10. Write 0 below the tens column and carry over 1 to the hundreds column. Add the hundreds column. 3 plus 4 plus 1 is equal to 8. Write 8 below the hundreds column. Now add the thousands column. 2 plus 3 is equal to 5. We get a total of 5,801. Now add the first number 1,234 to the total arrived. 5,801 plus 5,801 plus 1,234. Add ones column. 1 plus 4 is equal to 5. Add tens column. 0 plus 3 is equal to 3. Add hundreds column. 8 plus 2 is equal to 10. Write 0 in the hundreds column and carry over 1 to the thousands column. Add thousands column. 5 plus 1 plus 1 is equal to 7. We get the same answer, 7,035. Additive property of 0. 0 has got no value. So, when you add 0 to a number, the sum is the number itself. Let us find the sum of 4,567 plus 0 and 0 plus 4,567. Therefore, 4,567 plus 0 is equal to 4,567 and 0 plus 4,567 is equal to 4,567. Now, let us do some word problems on addition. Example. In a bookshop, there are 2,121 moral story books, 1,443 nursery rhyme books, and 3,421 pictorial books. How many books are there in all in the bookshop? Now arrange them in columns. Number of moral story books is equal to 2,121. Number of nursery rhyme books is equal to 1,443. Number of pictorial books is equal to 3,421. Add the ones first. 1 plus 3 plus 1 is equal to 5. Add the tens now. 2 plus 4 plus 2 is equal to 8. Add the hundreds. 1 plus 4 plus 4 is equal to 9. Add the thousands. 2 plus 1 plus 3 is equal to 6. The total number of books in the shop is equal to 6,985. We can also do addition by breaking into tens and ones, collecting tens together and ones together, adding tens and ones separately. Add 45 and 56. 45 plus 56. 40 plus 5 plus 50 plus 6. 40 plus 50 plus 5 plus 6. 90 plus 11. 101. Subtraction. Subtraction without borrowing. Let us first learn subtraction without borrowing. Step 1. In the given two numbers, find out which is greater and which is smaller. Step 2. Arrange the numbers in a column, putting the greater number on the top and the smaller number below that. Step 3. Subtract ones from ones, tens from tens, hundreds from hundreds, and finally thousands from the thousands below. Let us see an example. Subtract 4,521 from 6,852. 6,852 is the greater number. Arrange them in a column one below the other. Now start subtracting. Subtracting ones. 2 ones minus 1 ones is equal to 1 1. We write 1 under the ones column. Subtracting tens. 5 tens minus 2 tens is equal to 3 tens. We write 3 under the tens column. Subtracting hundreds. 8 hundreds minus 5 hundreds is equal to 3 hundreds. We write 3 under the hundreds column. Subtracting thousands. 6 thousands minus 4 thousands is equal to 2 thousands. We write 2 under the thousands column. Thus, 6,852 minus 4,521 is equal to 2,331. Example 2. Find the difference between 4,061 and 4,572. Here, both the given numbers have the same 4 digits. Their digits at the thousands place are the same. So, find out the greater number by comparing the hundredth place. 5 is greater than 0. So, 4,572 is greater than 4,061. Now, arrange them in a column. Subtract ones. 2 minus 1 is equal to 1. Subtract tens. 7 minus 6 is equal to 1. Subtract hundreds. 5 minus 0 is equal to 5. 4,572 minus 4,061 is equal to 511. Subtraction with borrowing. In the given two numbers, when the digit to be subtracted is bigger than the corresponding digit, we borrow 1 from the previous digit in the first number. I will explain this in an example. Take two numbers, 5,852 and 3,625. Arrange them in a column. Subtract the ones. Here we cannot subtract 5 from 2 because 5 is greater than 2. In that case, we should borrow 1 from the tens of the first number, that is from 5. Now, 2 becomes 12. Now, we can deduct 5 from 12. So, 12 minus 5 is equal to 7. Now, write 7 below the ones column. Subtract the tens. From 5 we have borrowed 1. This will reduce its value to 4. Now, deduct 2 from 4. So, 4 minus 2 is equal to 2. Write 2 below the tens column. Subtract the hundreds. Deduct 6 from 8. 8 minus 6 is equal to 2. Write 2 below the hundreds column. Subtract the thousands. 5 minus 3 is equal to 2. Write 2 below the thousands column. Thus, we get 5,852 minus 3,625 is equal to 2,227. Word problem on subtraction. Problem 1. A shopkeeper earned rupees 5,545 and spent rupees 3,523 in a month. How much money was left with him? Earnings of the shopkeeper is equal to rupees 5,545. Expenses of the shopkeeper, which is equal to rupees 3,523. Money left with him is, subtract ones. 5 minus 3 is equal to 2. Subtract tens. 4 minus 2 is equal to 2. Subtract hundreds. 5 minus 5 is equal to 0. Subtract thousands. 5 minus 3 is equal to 2. Money left with him is rupees 2,022. Let us see one more problem. Problem 2. The sum of two numbers is 6,540. One of them is 2,585. What is the other number? Sum of two numbers is equal to 6,540. One of the numbers is equal to 2,585. The other number is equal to, subtract ones. You cannot subtract 5 from 0. Therefore, borrow 1 from the tens column. That is 4. 10 minus 5 is equal to 5. Write 5 below the ones column. Subtract tens. Now you have only 3 left with the greater number in the tens column. You cannot subtract 8 from 3. Therefore, borrow 1 from the hundreds column. You get 13. 13 minus 8 is equal to 5. Write 5 below the tens column. Subtract hundreds. In the hundreds column of the greater number, you have only 4. You cannot deduct 5 from 4. Therefore, borrow 1 from the thousands column. Now you get 14. 14 minus 5 is equal to 9. Write 9 below the hundreds column. Now subtract thousands column. You have 5 in the thousands column of the greater number. 5 minus 2 is equal to 3. Write 3 below the thousands column. So, 6,540 minus 2,585 is equal to 3,955. Word problems on addition and subtraction. Mohan had rupees 10,000 cash with him. He bought a dress for rupees 3,000 and a table for rupees 5,000. How much money is left with him? Cost of the dress is equal to 3,000. Cost of a table is equal to 5,000. Total amount spent is equal to 3,000 plus 5,000 is equal to 8,000. Money left with him is equal to 10,000 minus 8,000, which is equal to 2,000. Money left with Mohan is rupees 2,000. "26. 3 13s are 39. 3 into 13 is equal to 39. 4 13s are 52. 4 into 13 is equal to 52. 5 13s are 65. 5 into 13 is equal to 65. 6 13s are 78. 6 into 13 is equal to 78. 7 13s are 91. 7 into 13 is equal to 91. 8 13s are 104. 8 into 13 is equal to 104. 9 13s are 117. 9 into 13 is equal to 117. 10 13s are 130. 10 into 13 is equal to 130. 14 tables. 1 14s are 14. 1 into 14 is equal to 14. 2 14s are 28. 2 into 14 is equal to 28. 3 14s are 42. 3 into 14 is equal to 42. 4 14s are 56. 4 into 14 is equal to 56. 5 14s are 70. 5 into 14 is equal to 70. 6 14s are 84. 6 into 14 is equal to 84. 7 14s are 98. 7 into 14 is equal to 98. 8 14s are 112. 8 into 14 is equal to 112. 9 14s are 126. 9 into 14 is equal to 126. 10 14s are 140. 10 into 14 is equal to 140. 15 tables. 1 15s are 15. 1 into 15 is equal to 15. 2 15s are 30. 2 into 15 is equal to 30. 3 15s are 45. 3 into 15 is equal to 45. 4 15s are 60. 4 into 15 is equal to 60. 5 15s are 75. 5 into 15 is equal to 75. 6 15s are 90. 6 into 15 is equal to 90. 7 15s are 105. 7 into 15 is equal to 105. 8 15s are 120. 8 into 15 is equal to 120. 9 15s are 135. 9 into 15 is equal to 135. 10 15s are 150. 10 into 15 is equal to 150. Multiplication is repeated addition. We will study this with the help of number line. We have the number line with numbers from 0 to 20 with 20 equal divisions. Let us now find the answer of a sum 3 into 6 with the help of a number line. For this, take a move from 0 to 3, then 3 to 6, 6 to 9, 9 to 12, 12 to 15, and 15 to 18. We have a gap of 3 numbers each time for 6 times and we reach 18. So, 3 into 6 is equal to 18. 3 plus 3 plus 3 plus 3 plus 3 plus 3 is equal to 18. The number to be multiplied is called the multiplicand. Here, the multiplicand is 6. The number you multiply by is called the multiplier. Here, the multiplier is 3. The answer is called the product. Here, the product is 18. Here, there is an addition of 3 for 6 times. So, multiplication is repeated addition. Let us see some examples for multiplying single-digit numbers which does not involve carry over. 4 plus 4 plus 4 plus 4 is equal to 4 into 4, which is equal to 16. 8 plus 8 plus 8 plus 8 is equal to 8 into 4, which is equal to 32. 7 plus 7 plus 7 plus 7 plus 7 is equal to 7 into 5, which is equal to 35. Now, let us see some examples for multiplying two-digit numbers which involve carry over. Multiply 65 into 5. Arrange them in place value column as shown here. For this, we use multiplication tables of 5. Now, multiply 5 into 5 in the ones place. The product will be 25. Write 5 below the ones column and carry over 2 to the tens column. Now, multiply 5 into 6. The product is 30. Add 2 to 30, which was carried over. We get 32. Now, write 32 below. The total product we arrive will be 325. When a number is multiplied by 1, the product is the number itself. For example, 4 multiplied by 1 will give you 4 itself. We write this as 4 into 1 is equal to 4. In the same way, when 1 is multiplied by any other number, it will give you the product as the number itself. For example, 1 multiplied by 160 will give you a product of 160 only. We write this as 1 into 160, which is equal to 160. When any number is multiplied by 0, it gives 0. For example, multiply 4 into 0 is equal to 0 plus 0 plus 0 plus 0, which is equal to 0. Similarly, 10 into 0 is equal to 0, and so on. When a multiplicand and a multiplier is interchanged, the product is the same. For example, 5 into 3 is equal to 15, and 3 into 5 is also equal to 15. In the same way, 6 into 2 is equal to 12, and 2 into 6 is equal to 12. This is called as the commutative property in multiplication. When 3 or 4 numbers are multiplied in any order, the product is the same. Example, 2 into 3 into 4 is equal to 3 into 2 into 4, which is equal to 4 into 3 into 2. The product of all the 3 multiplications will be 24. This is called the associative property in multiplication. Multiplication by 10, 100, 1000. When you multiply a number by 10, 100 or 1000, we can use an easy method to find the product. Example, multiply 5 by 10, 100 and 1000. 5 into 10 is equal to 50. Here, take the 0 from 10 to the right of 5 and we get the product 50. 5 into 100 is equal to 500. Take the 2 zeros from 100 to the right of 5 and we get the product 500. 5 into 1000 is equal to 5000. Take the 3 zeros from 1000 to the right of 5 to get the product 5000. So, we can multiply easily when one of the number is 10, 100 or 1000 and so on. Multiplication of two-digit numbers using word problem. There are 15 apples in a basket. How many apples will be there in 8 baskets? Number of apples in one box is equal to 15. That is 15 plus 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 15. Number of apples in 8 baskets is equal to 15 into 8, which is equal to 120. Multiplication of three-digit numbers. Multiply 312 by 3. Step 1. Multiply 2 ones by 3. 2 ones into 3 is equal to 6 ones. Write 6 under the ones column. Step 2. Multiply 110 by 3. 110 into 3 is equal to 3 tenths. Write 3 under the tens column. Step 3. Multiply 3 hundreds by 3. Multiply 3 hundreds by 3. 3 hundreds into 3 is equal to 9 hundredths. Write 9 under the hundreds column. Hence, 312 into 3 is equal to 936. Distributive property of multiplication over addition. Whenever there is a difficulty in multiplying large numbers, this method of distributive property of multiplication over addition is used. There are totally 4 rows of 9 apples in each row. Divide the box and split the number of apples to 2 sections. In the first section, there are 4 rows of 4 apples fence each. 4 into 4 is equal to 16. In the second section, there are 4 rows of 5 apples each. 4 into 5 is equal to 20. Therefore, 4 into 4 plus 4 into 5 is equal to 16 plus 20, which is equal to 36. Division. Let us do some examples to revise the sums which we did in the previous class. 9 divided by 3 is equal to 3. 10 divided by 2 is equal to 5. 8 divided by 4 is equal to 2. Here, the answer is called the quotient. Division as repeated subtraction. We know that division is repeated subtraction. Let us learn this through an example. Take a packet of chocolates with 12 numbers. You have to distribute them among students so that each student gets 3 chocolates each. Find out how many children will get the chocolates. First, you give 3 chocolates to one child. You are left with 12 minus 3, which is equal to 9 pieces. Give another 3 chocolates to the second child. Now, you are left with 9 minus 3, which is equal to 6. Now give 3 chocolates to the third child. It will leave you with 6 minus 3, which is equal to 3 chocolates. You have only 3 chocolates now. Give them to the fourth child. You are left with 3 minus 3, which is equal to 0. So, you gave 12 chocolates to 4 children with 3 pieces to each child. To equally distribute 12 chocolates, we have repeatedly subtracted 3 from 12 for 4 times. We write this as 12 divided by 3 is equal to 4. Division as distribution. There are 4 groups of 5 cats each. To find out the total number of cats, we multiply 4 into 5 and we get 20. When you are asked to find out the number of groups, we use division. Total number of cats divided by the number in each group. That is, 20 divided by 5, we get the answer as 4 groups. Division on number line. Let us use a number line and find the answer for 10 divided by 2. To find 10 divided by 2 means to find how many 2's are there in 10. Look at the number line. Start from 10 and take back moves of 2 each to reach 0. How many moves did we go from 10 to reach 0? It is 5 moves. Hence, 10 divided by 2 is equal to 5. Let us see a division problem using pictures. From the given diagram, let us answer the following questions. How many balloons are there altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many balloons are there in each group? 1, 2. How many groups are formed? 1, 2, 3, 4, 5. How many 2's are there in 10? 5. Therefore, 10 divided by 2 is equal to 5. Long division. Example: divide 648 by 2. Step 1. Arrange the numerals below in the place value order. Step 2. Divide 6 hundreds by 2. 6 hundreds divided by 2 is equal to 300. Write 3 in the hundreds place in the quotient. Step 3. Bring down 4 tenths. Divide 4 tenths by 2. 4 tenths divided by 2 is equal to 2 tenths. Write 2 in the tens place in the quotient. Step 4. Bring down 8 ones. Divide 8 ones by 2. 8 ones divided by 2 is equal to 4 ones. Write 4 in the ones place in the quotient. Hence, 648 divided by 2 is equal to 324. Division with regrouping. Divide 735 by 3. Step 1. Arrange the numbers according to their place values. Step 2. Divide 700s by 3. 3 goes into 7 2 times. 3 into 2 is equal to 6. Write 2 in the hundreds place in the quotient and 6 below 7. 7 minus 6 is equal to 1. Step 3. Bring down 3 tenths. Now 100 plus 3 tenths is equal to 13 tenths. Divide 13 tenths by 3. 3 goes in 13 4 times. 3 into 4 is equal to 12. Write 4 in tens place in the quotient and 12 below 13. 13 minus 12 is equal to 1. Step 4. Bring down 5 ones. Now, 110 plus 5 ones is equal to 15 ones. Divide 15 ones by 3. 3 goes into 15 5 times. 3 into 5 is equal to 15. Write 5 in ones place in the quotient and 15 below 15. Now 15 minus 15 is equal to 0. The remainder is equal to 0. Thus the quotient is equal to 245 and remainder is equal to 0. Division with remainder. Divide 760 by 7. First, arrange the numbers. Step 2. Divide 700s by 7. 7 goes into 7 one time. Write 1 in the hundreds place of quotient and 7 below 7. Now divide 6 tens by 7. 7 does not go into 6. So, write 0 in the tens place of quotient and bring 0 ones down. Now divide 60 by 7. 7 goes into 60 8 times. Write 56 below 60. The remainder is 4. The quotient is 108 and the remainder is 4. Fractions. As studied in class 2, fractions is a part of a whole. Half. An apple or a circle or a paper strip can be cut in the middle to divide it into 2 equal parts. When something is divided into 2 equal parts, each part is called a half. It is written as 1 by 2 and read as 1 by 2. Let us shade half of the following figures. Shade half of this triangle. Shade half of this square. Shade half of this circle. Quarter. A circle or a paper or an apple can also be divided into 4 equal parts. Each part of the 4 parts is called a quarter. It is written as 1 by 4 and read as 1 by 4. Let us shade the quarter part of the following figures. Shade quarter part of this square. Shade quarter part of this rectangle. Shade quarter part of this circle. 2/4. When 2 parts of the 4 parts are taken, it is called as 2/4. It is written as 2 by 4 and read as 2 by 4. Let us shade 2/4 of the following figures. Shade 2 of the 4 parts of this square. Shade 2 of the 4 parts of this triangle. Shade 2 of the 4 parts of this rectangle. 3/4. When 3 parts of the 4 parts are taken, it is called 3/4. It is written as 3 by 4 and read as 3 by 4. Let us shade the 3/4 of the following figures. Shade 3 of the 4 parts of this square. Shade 3 of the 4 parts of this rectangle. Shade 3 of the 4 part of this circle. 1/8. A paper can be divided into 8 parts like this. When one part of the 8 parts are shaded, it is called 1/8. It is written as 1 by 8 and read as 1 by 8. When 2 parts are taken, it is 2 by 8 or 2 by 8. When 3 parts are taken, it is called 3 by 8 or 3 by 8. Other fractions. We have already read about halves, quarter, fourths and eighths. There are also other fractions called 1 by 3 or 1 by 3. When one part of the 3 parts is shaded, it is called 1/3. 1 by 5 or 1 by 5. When one part of the 5 parts is shaded, it is called 1/5. 1 by 6 or 1 by 6. When one part of the 6 parts is shaded, it is called 1/6. 2 by 3 or 2 by 3. When 2 parts of the 3 parts are shaded, it is called 2/3. 2 by 5 or 2 by 5. When 2 parts of the 5 parts are shaded, it is called 2/5. 2 by 6 or 2 by 6. When 2 parts of the 6 parts are shaded, it is called 2/6. Look at the following diagrams and write down the fraction. In this diagram, one part of the 4 parts is shaded, so it is 1 by 4. In this diagram, 2 parts of the 8 parts are shaded, so it is 2 by 8. In this diagram, 4 parts of the 8 parts are shaded, so it is 4 by 8. In this diagram, 5 parts of the 8 parts are shaded, so it is 5 by 8. Here, 3 parts of the 6 parts are shaded, so it is 3 by 6. Shade the parts of the diagram to represent the given fractions. 5 by 10 is the fraction. So, let us color 5 parts of the 10 parts. 1, 2, 3, 4, 5. 6 by 8 is the fraction. So, let us color 6 parts of the 8 parts. 1, 2, 3, 4, 5, 6. 7 by 9 is the fraction. So, let us color 7 parts of the 9 parts. 1, 2, 3, 4, 5, 6, 7. 3 by 6 is the fraction. So, let us color 3 parts of the 6 parts. 1, 2, 3. 4 by 8 is the fraction. So, let us color 4 parts of the 8 parts. 1, 2, 3, 4. Comparison of fractions. Let us find out which fraction is greater from the given figures. The given fraction is 1 by 4 and 2 by 4. Here, both the denominators are the same. So, compare the numerator. There is 1 in the first number and 2 in the second number. Which is greater? 2 is the greater number. Therefore, 1 by 4 is smaller than 2 by 4. In this given fraction, 2 by 4 and 3 by 4, 3 is greater. So, 2 by 4 is smaller than 3 by 4. In this fraction, 3 by 4 and 4 by 4, 4 is greater. So 3 by 4 is smaller than 4 by 4. When the denominator is the same, the higher the numerator, the greater is the fraction. Let us try some examples. Compare the fractions and write the smaller than or greater than sign. The given fractions are 3 by 9 and 8 by 9. The denominators are the same. So, compare the numerators. 8 is greater than 3. So, 3 by 9 is smaller than 8 by 9. Here, the fractions are 7 by 8 and 3 by 8. The denominators are the same. So, compare the numerators. 7 is greater than 3. So, 7 by 8 is greater than 3 by 8. In the same way, in these fractions, 9 by 12 and 8 by 12, 9 by 12 is greater than 8 by 12. In the fractions 6 by 7 and 4 by 7, 6 by 7 is greater than 4 by 7. And in these fractions 2 by 5 and 4 by 5, 2 by 5 is smaller than 4 by 5. Arrange the following fractions in ascending order. The given fractions are 3 by 11, 2 by 11, 5 by 11, 1 by 11, 8 by 11 and 4 by 11. Now let us arrange them in ascending order, that is, from smaller number to greater number. As the denominators in all the fractions are the same, let us compare the numerator alone. The smallest number found is 1. So, 1 by 11 is the smallest fraction. Next comes 2 by 11. Next, 3 by 11. Then comes 4 by 11, 5 by 11, and finally 8 by 11. Arrange the following fractions in descending order. The given fractions are 4 by 7, 1 by 7, 6 by 7, 3 by 7, 2 by 7, and 5 by 7. Let us now arrange them in descending order, that is, from the greater number to the smaller number. As the denominators in all the fractions are the same, let us compare the numerator alone. The greatest number is 6. So, 6 by 7 is the greatest fraction among the given fractions. Now find the next smaller fraction, it is 5 by 7. Then comes 4 by 7. Then 3 by 7. Next is 2 by 7. And finally 1 by 7. Addition of fractions with same denominator. This strip is divided into 8 equal parts. 2 parts or 2 by 8 is shaded in red. 3 parts or 3 by 8 is shaded in blue. To find out the total shaded parts, add 2 by 8 plus 3 by 8, which is equal to 5 by 8. When the denominators are the same, we can add both the fractions by adding the numerators alone. Let us try some examples. Sum 1. Add 3 by 8 plus 1 by 8 plus 2 by 8. The denominators are the same 8. So, add the numerators, which is 3 plus 1 plus 2, which is equal to 6. So, the answer is 6 by 8. Sum 2. Add 4 by 10 plus 2 by 10 plus 3 by 10. The denominators are the same number 10. On adding the numerator, that is 4 plus 2 plus 3, we get 9. So, the answer is 9 by 10. Sum 3. Add 2 by 6 plus 1 by 6 plus 3 by 6. As the denominators are the same number 6, let us add the numerators 2 plus 1 plus 3. We get 6. So, the answer is 6 by 6. Subtraction of fractions with the same denominator. This strip contains 7 parts, that is 7 by 7. Remove 2 parts from the strip. To do that, we will have to deduct 2 parts from 7 parts. Subtract 2 by 7 from 7 by 7. As the denominators are the same, deduct the numerator 7 minus 2, which is equal to 5. So, the answer is 5 by 7. Let us try some examples. Sum 1. Subtract 2 by 6 from 5 by 6. The denominators are the same. Deduct the numerator. 5 minus 2 is equal to 3. So, the answer is 3 by 6. Sum 2. Subtract 1 by 10 from 9 by 10. The denominators are the same. So, deduct the numerators, that is 9 minus 1, which is equal to 8. So, the answer is 8 by 10. Geometry. Point. A dot represents a point. Mark a dot on a piece of paper. We name a point by a capital letter, say A, B, P or Q. Here we name the dot as P. We say that P is a point. A point has no dimensions. It has no length, no breadth or thickness. Line segment. When 2 points are connected, it is said to be a line. Mark 2 points on a paper and name them A and B. With the help of a ruler, join both the dots. This is called a line segment AB. This is written as AB. Properties of a line segment. A line segment has 2 end points. A line segment has a beginning and an end. A line segment is a part of a line. A line segment has a definite length but no breadth or thickness. Let us see some examples. In this figure, the line segments AB and CD meet at a point O. In this figure, the line segments P, Q and RS meet at R. Line. A line segment, when extended endlessly on both sides, is called a line, and we denote it as A, B. Properties of a line. A line has no end points. It has no definite length. To denote a line, we draw a line segment and draw arrows at both the ends. Ray. When we join 2 points P and Q and extend it on one side from point P or point Q, it is called a ray. Since a ray is endless in one direction, it cannot be drawn on a paper. We denote a ray by drawing an arrow at the end of the extended line. Properties of a ray. A ray consists of many points. A ray has a beginning, but it has no end. A ray extends indefinitely on one side only. The length of a ray cannot be measured. Different types of lines. Horizontal lines. When a line is drawn straight from left to right in the way a pencil lies on a table, it is called a horizontal line. In this figure, the line AB is a horizontal line. Vertical lines. When a line is drawn straight from top to bottom like a pole standing in a ground, it is called a vertical line. In this figure, the line CB is a vertical line. Oblique or slanting line. When a line is drawn in a slanting position like that of a ladder in a slanting position, it is called an oblique line. In this figure, line EF is an oblique line. Measuring line segments. When an existing line segment has to be measured, a ruler can be used. Put the ruler along the line in such a way that one of its edges touches both the points A and B, and the zero mark of the ruler is at A. Now read the ruler mark at B. The reading of the scale at B gives the length of the line segment AB in centimeters. Here it reads 5 centimeters. When you need to draw the line for a given measurement, follow these steps. Step 1. Put the ruler on the paper and hold it firmly. With the help of a sharp pencil, mark a point P against the zero mark of the ruler and a point Q against the 6 cm mark of the ruler. Step 3. Move the pencil from P to Q along the edge of the ruler. Thus, we obtain the line segment PQ. Plane figures. A rectangle, a square, a triangle, or a circle are called plane figures. Square. A, B, C, D is a square. It has 4 sides: A, B, B, C, C, D, and A, D. It has 4 corners: A, B, C, and D. All the sides of a square is equal: A, B, B, C, C, D, and A, D. Rectangle. A, B, C, D is a rectangle. It has 4 sides: A, B, B, C, C, D, and A, D. It has 4 corners: A, B, C, and D. In a rectangle, all the sides are not equal, but opposite sides are equal. Side A, B is equal to side C, D, and side B, C is equal to side A, D. Triangle. A, B, C is a triangle. It has 3 sides: A, B, B, C, and AC. It has 3 vertices: A, B, and C. Circle. A circle has 1 curved side. It has no corners. Let us do some examples based on the shapes. Look at the picture and count the number of triangles in each figure. In figure 1, we have 1, 2, 3, 4, 5, 6. 6 triangles. In figure 2, we have 1, 2, 3, 4, 5 triangles. In figure 3, we have 1, 2, 3, 4, 5, 6, 7, 8 triangles. Look at the picture and count the number of rectangles in each case. In figure 1, we have 1, 2, 3, 3 rectangle. In figure 2, we have 1, 2, 3, 4, 5, 6. 6 rectangle. Solids. An object that occupies space is called a solid. A cuboid, cube, cylinder, sphere, and cone are called solids. Cuboid. A cuboid has 6 rectangular faces. The opposite faces of a cuboid are identical. A cuboid has 12 edges, namely AB, BF, EF, AE, AD, BC, FC, EH, DC, CG, GH, and DH. 3 edges of a cuboid meet at a point called a vertex. A cuboid has 8 vertices, namely A, B, C, D, E, F, G, and H. Examples of a cuboid are matchbox, book, box, etc. Cube. When the length and the breadth of a cuboid are equal, it is said to be a cube. Examples of a cube are ice cubes, sugar cubes, dice, etc. Cylinder. A cylinder has 2 plane faces and 1 curved face. It has 2 edges, both of which are circular. A cylinder has no vertex. The base and the top of a cylinder are of the same shape and size. Examples of cylinder are gas cylinder, etc. Sphere. A sphere has no edges or corners. It has only 1 curved face. The objects which are in the shape of a ball are known as a sphere. Cone. A cone has 1 plane surface, which is its base, and a curved face. It has only 1 edge and 1 corner. The corner is also called a vertex. Examples of a cone are birthday caps, cone ice creams, etc. Money. For our daily needs, we purchase goods from the market. We need money to pay to the shopkeepers in exchange for the goods. In the Indian currency, we have coins and notes. This is a 10 paise coin. This is a 20 paise coin. This is a 25 paise coin. This is a 50 paise coin. This is a 1 rupee coin. This is a 2 rupee coin. This is a 5 rupee coin. This is a 1 rupee note. This is a 2 rupee note. This is a 5 rupee note. This is a 10 rupee note. This is a 20 rupee note. This is a 50 rupee note. This is a 100 rupee note. This is a 500 rupee note. This is a 1000 rupee note. Expressing money in words. This is written in figures as rupees 10 and in words as rupees 10. This is written in figures as rupees 50.25 and in words as rupees 50 and paise 25 only. Expressing money in figures. We use the symbol RS for rupees and P for paise. Thus, 85 rupees and 85 paise is written as rupees 85.85 paise. When paise has to be written separately, we write it as 0.85 paise. Here, 0 denotes that there is no rupee. Conversion of rupee into paise. We know that 1 rupee is equal to 100 paise. So, to convert rupees into paise, we multiply the amount in rupees by 100. For example, 5 rupees is equal to 5 into 100 paise, which is equal to 500 paise. 15 rupees is equal to 15 into 100 paise, which is equal to 1500 paise. 100 rupees is equal to 100 into 100 paise, which is equal to 10,000 paise. Conversion of rupee and paise into paise. See an example. Rupees 10.75 is equal to rupees 10 and 75 paise, which is equal to 10 into 100 plus 75, which is equal to 1000 plus 75, which is equal to 1075. If rupees and paise are written in figures as 10.75, then to convert the whole into paise, simply remove the point. Conversion of paise into rupee. See an example. 1150 paise is equal to rupees 11.50 or 11 rupees and 50 paise. If a paise has to be converted into rupees, simply put a dot before the second digit from the right. Addition of money. Simpler method of addition. Example. Add 45 rupees, 50 paise and 30 rupees, 25 paise. Solution. Arrange the amounts in columns. Add ones. 0 plus 5 is equal to 5. Add tens. 5 plus 2 is equal to 7. Add hundreds. 5 plus 0 is equal to 5. Add thousands. 4 plus 3 is equal to 7. We get the answer as 7,575. Put the point in the same column as in the given amounts. We get 75.75. Hence, the given sum is rupees 75 and paisa 75. Addition by conversion. Example. Add 33 rupees and 25 paise and 44 rupees and 40 paise. Step 1. Convert the amounts into paise, that is, multiply by 100. 33.25 into 100 is equal to 3,325 and 44.40 into 100 is equal to 4,440. Step 2. Arrange the amounts in column. Step 3. Add the ones column. 5 plus 0 is equal to 5. Add the tens column. 2 plus 4 is equal to 6. Add the hundreds column. 3 plus 4 is equal to 7. Add thousands column. 3 plus 4 is equal to 7. The answer we get is 7,765. Step 4. Convert the sum into rupees and paise. That is, by dividing the number 7,765 by 100, we get 77 rupees 65 paise. Let us do a word problem in addition of money. Mr. Mohan purchased tomatoes for 12 rupees and 70 paise, onions for 15 rupees and 50 paise, potatoes for 9 rupees and 50 paise, and brinjals for 5 rupees and 25 paise. How much money did he totally spend on vegetables? Solution: cost of tomatoes 12 rupees 70 paise, cost of onions 15 rupees 50 paise, cost of potatoes 9 rupees 50 paise, cost of brinjals 5 rupees 25 paise. Arrange the amounts in column. Add ones column. 0 plus 0 plus 0 plus 5 is equal to 5. Add tens column. 7 plus 5 plus 5 plus 2 is equal to 19. Write 9 in the tens column and carry over 1 to the hundreds column. Now add hundreds. 1 plus 2 plus 5 plus 9 plus 5 is equal to 22. Write 2 in the hundreds column and carry over 2 to the thousands column. Add the thousands column. 2 plus 1 plus 1 is equal to 4. Put the point in the same column of the answer. We get rupees 42 and 99 paise. Total amount is equal to 42 rupees 95 paise. Hence, Mr. Mohan had spent 42 rupees 95 paise for vegetables. Subtraction of money. Simpler method of subtraction. Example: subtract 13 rupees 45 paise from 65 rupees 65 paise. Solution: Step 1. Arrange the amounts in columns. Step 2. Subtract the numbers as we regularly do in subtraction. Subtract ones. 5 minus 5 is equal to 0. Subtract tens column. 6 minus 4 is equal to 2. Subtract hundreds column. 5 minus 3 is equal to 2. Subtract thousands column. 6 minus 1 is equal to 5. Step 3. Write the difference below. Rupees 65 65 paise, rupees 13 45 paise, rupees 52 20 paise. Hence, the difference between the given amounts is 52 rupees 20 paise. Subtraction by conversion. Example: subtract 24 rupees 20 paise from 56 rupees 40 paise. Solution: Step 1. Convert them into paise. To convert, we should multiply by 100. 24.20 into 100 is equal to 2420, and 56.40 into 100 is equal to 5640. Step 2. Arrange them in columns. Step 3. Subtract ones. 0 minus 0 is equal to 0. Subtract tens. 4 minus 2 is equal to 2. Subtract hundreds. 6 minus 4 is equal to 2. Subtract thousands. 5 minus 2 is equal to 3. We get 3,220. Step 4. Put a dot in the difference amount in the dots column. We get 32.20 as the answer. Let us do a word problem in subtraction of money. Example: Miss Rita's total salary is rupees 5,000. She spent rupees 1,500 for rent, 500 for provision and 250 for milk. What is the balance amount she has in hand? Solution. Miss Rita's total salary is rupees 5,000. Amount spent for rent is rupees 500. Balance on hand is rupees 4,500. Amount spent for provision is rupees 500. Balance on hand is rupees 4,000. Amount spent for milk is rupees 250. Balance in hand is rupees 3,750. Hence, the balance amount with Miss Rita is rupees 3,750. Multiplication of money. Multiplication of money is similar to multiplication of ordinary numbers. The only thing which you will have to remember is to put the point at the proper place to separate rupees and paise. Let us see an example. Multiply 7 rupees 25 paise by 4. Multiply 4 with the number in the ones column. 4 into 5 is equal to 20. Write 0 below the ones column and carry over 2 to the tens column. Multiply 4 with a number in the tens column. 4 into 2 is equal to 8. Add the carry over number 2 to the product. We get 10. Write 0 below the tens column and carry over 1 to the hundreds column. Now 4 with the number in the hundreds column. 4 into 7 is equal to 28. Add the carry over number 1 to the product. We get 29. Write 9 below the hundreds column and 2 in the thousands column. The answer we get is 2,900. Now put the point at the proper place. The answer is rupees 29. That is rupees 29 and paise none. Word problem for multiplication of money. Example. The cost of 1 liter of milk is 10 rupees. What is the cost of 5 liters of milk? Cost of 1 liter is equal to rupees 10. Cost of 5 liters is equal to 10 into 5, which is equal to 50 rupees. Multiply the ones column 5 into 0, which is equal to 0. Write 0 in the ones column. Multiply the tens column. 5 into 0 is equal to 0. Write 0 in the tens column. Multiply the hundreds column. 5 into 0 is equal to 0. Write 0 in the hundreds column. Multiply the thousands column. 5 into 1 is equal to 5. Write 5 below the thousands column. We get 5,000. Now put the point before the tens position as in the problem. The total cost of 5 liters of milk is rupees 50. Time. Calendar. This is the calendar for the year 2009. It helps us to know the year, the month, day and the date. There are altogether 12 months in a year. Let us learn the names of the months. January, February, March, April, May, June, July, August, September, October, November, and December. All these months do not have the same number of days. Months with 31 days are January, March, May, July, August, October, and December. Months with 30 days are April, June, September, and November. February is the month with only 28 days, and once in 4 years, there are 29 days in that month. Let us learn the days of a week. A month has 4 weeks, and each week has 7 days, and they are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Conversion. We have 4 types of counts for a month, that is 28, 29, 30 or 31 days as we studied. But when you do conversion of months into days, we take only 30 days. Let us convert 5 months into days. 1 month is equal to 30 days. 5 months is equal to 5 into 30, which is equal to 150 days. Let us convert 6 weeks into days. 1 week is equal to 7 days. 6 weeks is equal to 6 into 7, which is equal to 42 days. Let us find out the number of days in 3 years. 1 year is equal to 365 days. 3 years is equal to 3 into 365, which is equal to 1095 days. Clock. The time of a day can be known by looking into a clock. Look at the face of the clock shown here. There are 12 numbers in the face of the clock which are arranged in equal gaps of 5 small equal divisions. If you put all together, we get 12 into 5, that is 60 small divisions. The face of the clock also has 2 hands, one long hand and one short hand. The longer hand is called the minutes hand, the shorter hand is called the hour hand, and the 60 equal divisions are the seconds. The long hand has to make 1 full round to make 1 hour. 60 minutes make 1 hour. 24 hours make 1 day. Have a look at these clocks and write down the time. The short hand shows 8 and the long hand shows 12. So the time is 8 o'clock. The short hand shows 11. The long hand shows 12. So the time is 11 o'clock. The short hand shows 5. The long hand shows 12. So the time is 5 o'clock. Let us draw the hands on the clock for the following time. 4 o'clock. Short hand towards 4 and the long hand towards 12. 7 o'clock. Short hand towards 7 and the long hand towards 12. 2 o'clock. Short hand towards 2 and the long hand towards 12. Let us now know how to find the other times, half past and quarter past. When the minute is at 6, we call it as half past. When the long hand shows the number 6, we call it as half past. Look at the clock. The hour hand lies at 6. It denotes 30 minutes and the short hand lies between 3 and 4. So we call it as half past 3. In this picture, the long hand shows 6 and the short hand lies between 4 and 5. We call it as half past 4. When the long hand shows the number 3, we call it as quarter past. Let us see some examples. In the clock, the long hand shows 3 and the short hand is just above 9. We call it as quarter past 9. In this clock, the long hand shows 3 and the short hand is just above 6. So we call it as quarter past 6. When the minute hand shows other numbers. When the minute hand is at 1, it denotes 5 minutes past. When the minute hand is at 2, it denotes 10 minutes past. When the minute hand is at 4, it denotes 20 minutes past. When the minute hand is at 5, it denotes 25 minutes past. And so on. Find out from each of these clocks. In this clock, the short hand is far above 10 and nearing 11, and the long hand is at 9. So, the time is 10:45. In this clock, the short hand is between 7 and 8, and the long hand is at 7. So, the time is 7:35. In this clock, the short hand is just after 4 and the long hand is at 2. So the time is 4:10. Conversion of time. Conversion of hours into minutes. Let us find out how many hours are there in 6 days. 1 day is equal to 24 hours. 6 days is equal to 6 into 24, which is equal to 144 hours. Let us find how many minutes are there in a day. 1 hour is equal to 60 minutes. 1 day is equal to 24 hours. Total minutes in a day is equal to 24 into 60, which is equal to 1440 minutes. Conversion of minutes into seconds. Convert 50 minutes into seconds. Since 1 minute is equal to 60 seconds, to convert minutes into seconds, we multiply the given number of minutes by 60. Hence, 50 minutes is equal to 50 into 60, which is equal to 3000 seconds. Now, let us convert 20 minutes and 30 seconds into seconds. 1 minute is equal to 60 seconds. So, 20 minutes is equal to 20 into 60, which is equal to 1200 seconds. Hence, 20 minutes and 30 seconds is equal to 1200 seconds plus 30 seconds, which is equal to 1230 seconds. AM and PM. A day has 24 hours. We divide this time period into 2 equal parts of 12 hours each. One for the morning hours and the other for the evening hours. In the morning, as the clock shows 7 o'clock, we say the time is 7 o'clock in the morning. We write it as 7 a.m. In the evening, as the clock shows 5 o'clock, we say the time is 5 o'clock in the evening. We write it as 5 p.m. Morning hours are thus called AM and evening hours are called PM. That is 1 a.m., 2 a.m., 3 a.m. and when the clock strikes 12, we call it as noon or midday. And after 12 noon, we call the hours as afternoon and write it as 1 p.m., 2 p.m., 3 p.m. and so on till 12 in the midnight and so on. Let us try some examples. Just fill in the time with AM and PM. I get up at 6 o'clock in the morning. We write it as 6 a.m. I go to school at 8 o'clock in the morning. We write it as 8 a.m. I eat my lunch at 1 o'clock in the afternoon. We write it as 1 p.m. I come back home by 3 o'clock in the afternoon. We write it as 3 p.m. I go to play at 5 o'clock in the evening. We write it as 5 p.m. I eat my dinner at 8 o'clock in the night. We write it as 8 p.m. I go to bed at 9 o'clock at night. We write it as 9 p.m.